Okay, so can anybody share a shortcut with me? Yeah, Pete?
Y can't equal 0?
Yeah, y can't equal 0. There's no dots along there, so we don't need to consider doing the slope field there. What else, though, could we maybe use? Is there anything? Okay, so tell me, speak up. I heard some. When x is negative 1, the whole thing is going to be 0, so then we can just do this. Okay, anybody else share a shortcut with us? Yeah.
I think you did. Isn't it when x is
Oh, sorry, yeah.
negative 1?
My fault. When x is negative 1, there we go. Okay, so when x is negative 1, they're all zeros. That's a third of the work done. I don't know if there is another shortcut. What do you think? 0. Well, okay, let's talk about 0. When x equals 0, yeah, you basically have 1 over y. So we can look at these reciprocals. That'll be negative 1/2 here. So negative 1/2, probably something like that. This will be negative 1. Then this will be 1 over 1, 1 over 1/2. And then when we go to x equals 1, you got 2 over y. So this will be negative 1. Maybe that's a little steep. I'll draw it a little less steep. Then at this would be negative 2. This would be positive 2. And this would be 1. So that's okay. That looks like a pretty decent slope field. Be careful you don't go into autopilot, though, just drawing your slope field, because you'll notice it says sketch the curve that passes through the point 0, negative 1. Pardon me? I hope I'm on the right page here. That's right, 0, negative 1, yeah. Okay. So what that means is if I was to put the curve through here, where would the curve go? Now, if you're sort of looking at the way the slope field is going, you know, this is sort of the way I would see it happening as it went through this point. It's angling itself this way, and then as it, you wouldn't draw it with these arrows. I'm just trying to give you a hint as to how I'm finding the curve. It's headed in that direction, and then once it gets there, do you notice as it goes lower, what's happening to that slope? Is it getting steeper or flatter, or what's going on? Like as it goes lower towards negative 2, take a look. What's happening to it? It goes flatter, right? It's not as dramatic. So that means as I fall down, I'm not going to be as steep either. And then I'm probably not going to be as steep as I go there. And then as I go through the curve, when I hit this point, I've got to line up to this negative 1. So it's going to, maybe that line was a bit too long, but at some point it's going to then start to curve a bit steeper. Not that steep. So say something like, I don't know, let's go with that. And as I mentioned to the group yesterday, typically the way the exam would mark this is they would agree on some points, and they would say, okay, when you go through here, that's the slope field, so yep, your graph is tangent. When they go through here, this might be what the slope field looks like. Yep, your graph looks tangent. So as long as you're lining up to the slope fields, you would get marks for this. We have to continue on the other side, of course. So let's try and sketch out what we see here. So again, if I'm going in this direction, I would have started this way. And then you have to think about what's happening to the slope again. As I go towards this side, it's going to go flat when it hits this negative 1. But in the meantime, there's going to be a problem. You know, you can't go like this and say, oh yeah, it's going to do this. Right? How come? How come I can't draw it all the way like that? Because what? the bounds? Yeah. It's not defined there. So the way you got to think of a slope field is a slope field is pointing you where to go. It's not giving you the map that tells you that from, a function gives you the whole, nice way of plotting points and drawing the line through them. A slope field only tells you, if you're here right now, this is where you head in the next position. So it keeps telling me, head in this direction, and boom, you explode because you can't go any further. But when you hit that point where it's undefined, you're stuck. You can't ask where to go next. Even though you'd like to draw your pencil further, you cannot do that because no one's telling you where to head from there. You don't know. So that is literally what you would leave your answer as. You'd leave a hole in the graph, and you would stop when you hit an undefined point. Okay? So if you're doing this in your notes, you may want to include that there. When it's undefined, don't cross the boundary. That is a fairly, if they were to throw if I was to tell you there's one tricky move they do in a differential equations question, aside from the ones we've already tried that have been, fairly consistent, that's the one thing that they might throw at you to see if you understand. And the reason it is that way is, remember, a slope field just tells you if I'm standing at this particular spot, there's the direction you go next. If there's nowhere to stand, there's no direction to keep going. You're stuck. Okay. All right, so let's move on here. This one says, find all the spots where the derivative equals -1. So here's our equation. Oops. X plus 1 over y. So really what we're saying is if we put these two things together, we want -1 to be x plus 1. I don't know why I keep drawing that. X plus 1 over y. That gives me an equation -y equals x plus 1. Now I know it's tempting to just be able to say, got to keep this in my equation. I know it's tempting that you want to be able to come up with a nice inequality here, but in this case it's not going to happen. It's a relationship. If you're on, what do you recognize this as? If I was to ask, like, if you got a little brother or sister in, say, grade 10, what would they tell you this is? What is that equation? Oh, come on, it starts with an L. It's a line, yeah. It's just the equation of a line. So what that means is if you were to look at this graph, here's the line at -1 and then going down. If I was to walk along that line, I would find that the slope is -1 at each of those points. So the red, if I walked along there through the slope field, those red dashes would be -1 all the way along there. Okay, so that's where you find it equal to -1. Okay, the last part asks us for the initial the solution with initial condition f of 0 equals -2. So we're going to have to go and separate the variables. And that's going to give us y dy equals x plus 1 dx. And then we'll integrate both sides. Okay, and then I'll rearrange this. I'll solve it for y. So if I multiply everybody by 2, and remember there's that funny math with constants, right? 2 times a constant, it's just still the constant. So y is going to be equal to plus or minus square root x squared plus 2x plus c. And the particular spot that we're looking for is 0 and -2. So I'll put that into the values. Okay, so somebody think ahead here. Is there going to be a problem with this equation the way I've written it down? What's the problem? You're right, there is. There's only one variable where I've written the last step. Shoot. It won't be negative. It's a square root. It won't be negative. So square root, and then the other side is -2. And here, let me just, it's going to disappear for a sec. There we go. It's not going to be a negative, but you notice I had a choice of plus and minus. I just chose the wrong half here. I should have put a negative in front. So why do you think it's either side? What do you think happens that makes it pick one side and not go all the way through? Do you remember in our picture what happened? Yeah, it's undefined. So basically it hits that 0. It's got to be on one side or the other, just like it is here. It's either all positive or all negative. So let's go ahead and we'll solve this. 2 is going to be the root of x squared plus 2x plus that constant. If I square both sides, this is the equation I end up with. So again, this is going to seem kind of strange, but subtracting a constant from both sides is still just a constant. We just throw that away, the negative. And then I'll try and factor what I can here, and hopefully something, will it factor? Doesn't look like it will. Somebody could have just mentioned that I didn't substitute in for x yet. That'll make this problem a lot easier. So I have a constant that's just going to be -4. And let's see here. The equation that we were working with was this one. And for the particular solution, ours was going to be y equals the negative side. So that means I'm going to have this. Now, if you really have the time and the luxury to do so, you also now have a graph. If you're not happy with your sketch from the slope field, you now actually have the function here. So you could go and plot some points through the slope field to make sure you're happy with the graph, right? But, assuming that you have the time to do so. Okay, so you could use this in your answer. But remember, this is for the particular solution when you have f of 0 equals -2. The one that we had to graph was different, right? You had to graph f of 0 equals -1. So that means you'd have to go through the same process using this initial condition if you wanted to do it that way. Yeah?
Should c be -c that you put on the other side there? Oh.
Yeah, it's that funny math with constants. But anyways, let's put this one aside. It's taken a little longer than normal.